The sun feels permanent. It rose this morning, it'll rise tomorrow, and somewhere deep in your mind it feels like it always will. But that's a comforting lie your brain tells you because the sun has an expiration date, and so does the ground you're standing on. There is a specific window of time already calculated by astrophysicists when our star will expand, reach out across nearly 100 million miles of empty space, and consume the Earth completely. And the strangest part, we can tell you roughly when. Right now, the sun is doing something violent and beautiful at its core. Every single second, it fuses 600 million tons of hydrogen into helium, and in that conversion, a tiny sliver of mass simply vanishes, turned into the light and heat that lets you exist. It's been doing this for 4.5 billion years. It has enough fuel to keep going for roughly 5 billion more, so you'd think we have nothing to worry about. But that number hides a trap, because the sun does not burn quietly and steadily until the day it runs out. It is slowly, relentlessly getting brighter right now. Here's the part almost nobody knows. As the sun fuses hydrogen, its core fills with helium ash, contracts, and heats up, which forces the sun to burn faster and shine hotter over time. It is about 30% brighter today than it was when it first ignited, and it keeps climbing. In roughly 1 billion years, not 5, the sun will be hot enough that Earth's oceans begin to boil away. Water vapor floods the atmosphere, traps even more heat in a runaway greenhouse effect, and our blue planet starts to look less like Earth and more like Venus. Long before the sun ever touches us, it will have already sterilized the surface. The end of life and the end of the planet are two completely different deadlines, but you came here for the swallowing. So let's talk about what happens when the core finally runs dry. In about 5 billion years, the sun exhausts the hydrogen in its center. Without that outward push of fusion, the core collapses inward under its own gravity and heats to staggering temperatures. The outer layers, in response, balloon outward. The sun begins to swell. It becomes a red giant, and this is where the story turns terrifying. As a red giant, the sun will expand to somewhere between 100 and 200 times its current size. Mercury, gone, vaporized in the first wave. Venus, engulfed and destroyed, and then it reaches for us. The surface of the swollen sun will balloon out to roughly the distance of Earth's orbit, close to 100 million miles of expansion. For a long time, astronomers argued about whether Earth would survive at the very edge, because here's a genuine twist. As the dying sun sheds its outer layers into space, it loses mass. And less mass means weaker gravity, which means Earth's orbit actually drifts outward, away from danger. So does Earth escape? The most detailed models say no. As the Earth pulls ahead in its widening orbit, it raises tides on the bloated surface of the sun, and those tides drag back on the planet, a gravitational friction that bleeds away its orbital energy. The Earth spirals inward faster than the loosening grip of the sun can let it flee. It loses the race. Our planet plunges into the outer layers of the red giant, is torn apart by friction and heat, and the atoms that once made up mountains and oceans and every person who ever lived dissolve into the body of the star that gave them life. The Earth ends inside the sun, and after that violence, something almost peaceful happens. The sun isn't massive enough to explode in a supernova. Instead, it gently puffs off its outer shell into a glowing cloud called a planetary nebula, one of the most gorgeous structures in the cosmos, and leaves behind its naked, dead core. A white dwarf, a cinder roughly the size of Earth, but so dense a teaspoon of it would weigh tons, glowing faintly with leftover heat, slowly cooling over trillions of years until it fades to black. That smoldering ember is the sun's true grave, and it will sit there in the dark long after everything we recognize is. Now, before this ruins your week, humanity will not be here to watch it. We have 1 billion years, maybe less, before the oceans boil, and that is the deadline that actually matters for life. 5 billion years from now, no human in any form we'd recognize will be clinging to this rock. Either we'll be long extinct, or we'll have become something that spreads beyond a single fragile world orbiting a single doomed star. The sun's death isn't really a prophecy of our ending. It's a countdown clock, ticking quietly in the sky, daring us to grow up and leave the nest before the house burns down. So here's what I keep coming back to. If you knew with certainty that your home had an expiration date written in the laws of physics, would that knowledge make you want to leave, or make every sunrise you have left mean a little more?